Hi everyone. Today I would like to go through what I've done on the hack day with AWS Glue. So what we'll cover here is I will explain what Glue is and what components does it have. And then I will try to go through some examples that I was done as part of the hack day. And then at the end I will go through what limitation um, would we be facing if we trying to use Glue for our new data platform. So what is Glue? So Glue is a fully managed ETL service for moving and transform data with your data sources. So basically, compare with our existing current um, data warehouse structure, we have to manage the Informatica server and also the DAC server, which is the server that does the ETL jobs. With Glue, we don't have to manage any of this because it will scale up and down automatically depending on the job that is running. Um, so Glue can read from various data sources, such as it can read from S3, RDS databases, Redshift, and Athena, and it also can write the results into a S3 bucket or RDS instance and also Redshift instance. So what components does Glue have? So the first thing is the crawlers. So what a crawler is like a tool that it can read the data sources and then transform those data sources definition into the data catalog. And for example, right, if we use the crawler to crawl a file in the S3 bucket, what it does is it gets a sample from the S3 file and then read the sample data, and then it will create the columns and tables and the column types in the data catalog. And next thing is what is a data catalog? Data catalog is like a central repository which stores all the table definitions that we use for the ETL jobs. So next one is jobs. So jobs is like just like a Python script which transforms the data and loading the data. Triggers is to run the jobs. So a trigger can be used to run just one job, or it can be trigger a job to run based on other job has been completed successfully. And dev endpoints is just like a development environment for us to create the jobs and testing our jobs. So in our terms with in terms of with our current data warehouse architecture, to me, jobs is pretty much like our Informatica mappings, and triggers is like the task that we run in the DAC. So let's now go through the UI of the AWS Glue. So this is the AWS Glue console. So as you can see, we have the data catalog, which contains the databases and tables, and connections is like if we want to connect to a RDS or Redshift instance, this is where we configure our connection settings. And crawlers is, as I explained before, is the crawler where you can read the sample data and create the table definitions in the databases. And then below that we have jobs. Jobs is like just a list of jobs that we have here, and inside the jobs that we have the ETL scripts in Python. And again, triggers is like how we run the jobs, and dev endpoint is like the dev environment that we have set up for Glue jobs testing. So let's start with the databases. So in data catalog, you list out the databases that you have. So databases to me is like it's like grouping of tables. So in here, it's not a physical database in here. So what it does is just like metadata definitions. So for example, the one I create, the database I create here is called test data. And within test data, you have tables. And tables are from different sources. So in here, I have sources from S3 and also sources from a Postgres database from RDS. So in here, so if I drill down to that Postgres database. So here are the columns and the data type. So you can do this manually. So you can create your databases and tables one by one and put in the columns one by one and specify the types one by one. But for example, if you have a table which is like 300 columns, that's like some of the Archie tables that we have, and it's quite um, a very hard and long task to create this manually. So that's where the crawlers are coming in. Before I go through crawlers, maybe I'll show you the connections here. So connections for here, the connections I've set up is what I've done before is I create an RDS instance, which is Postgres database. And in there, this is the endpoint. So what I'm doing here, right, to set this up is what I have to do is just go to the RDS here. And then in here, there's like only one instance, and that's the glue test. And then you scroll down. This is the endpoint. So CCFK4, and here is CCFK4. So what I did is I just put the endpoint in here, and then it will point to that database automatically. So this is a setup. So I have to put the connections details like that. That's the URL, and then the username and password for the database, and then just the VPC and subnets. And then for, yeah, maybe I'll also show you one of the example if I try to point the data to an S3 bucket. So this one like this. So that's the location, and then you can set the column names and the data types. And here when you edit a schema, you can edit the schema manually. And then when you save it, there will be a new version come up. So at the moment, this is the current version. And I think if I can, there's no previous version on this. Um, yeah, but if you change the schema, it will raise to a next version so you can track the previous version of the schema. So one thing to note with the schema updates, right? Once you update the schema, for example, this one, right? If say today the new file came up has an additional column and then you update the schema, when you try to read the older files which doesn't have the new column, um, or the column name has changed, then you will have an issue for that. So just an extra step to be mindful on that. Um, so that's tables, connections. Okay, crawlers. So the crawlers is um, like a tool that goes into the S3 bucket, read the file, and then create the tables for the database. So in here, right? So for this particular crawler, as you can see that's the name, and then we have we want to create this in the test data database, and these are the tables. So you just specify the file name or the location of the bucket, and then you will get a sample of the data and create those columns and the column types. So in here for this particular one, you can have multiple data store for used by one crawler, and every time you run a crawler, it will go through all the data store to update the schema definitions. And then so in here you just type the path, and then you just keep on adding it until you finish. And then once you done that, you can run the crawler, which basically just go through all those buckets and then get the sample file and update the data definitions. So that's the crawler. So moving on to the ETL. So these are the jobs. So the jobs that I want to show you is the test to delete and also the jobs to delete too. So for the test to delete. So in here it shows the history, when the job ran and how long it took, and it was successful or not. And details is just some um, the job settings, if it has a trigger or not. And then script is where you write your Python script. So let's go through these scripts to see what it does, right? So what I did for this is just like reading a table and then load the data into the database. So for example, this one is reading from here, create dynamic frame, Redshift win-loss source export. So I'll show you where this one is. So that's from the data catalog. So all the tables that it's using here is from the data catalog. So you can see that in the data catalog, you set up all the tables that you use for your jobs, and then in your jobs, you just reference the data in the data catalog. So in here, right, the database is Redshift win-loss source export. So in here, there should be a database called that. Yep, that's the one. And in the table that we can see, which table we're referencing now is W month D. So in here, there should be but W month D table. So we're getting the data from this table, which is from the S3 bucket. So what it does, we just read the data, and then we didn't do any transformation. As to how to do transformation is I was shown using Python script in the previous um, notebook presentation, so you can refer to that. Okay, so at the end, we try to write the data from the dynamic frame, which is this one here, the df dynamic, and then we write to the glue test Postgres, which is the connection that we had before, and then we just put the table name and then the database name, and that's all we have to do to write the data. So what this does is just read the data from the month table and then populate it into this sales movement table. That's all it does. And df dynamic. Yep, so we have that. And then the next job is this one here, job to delete number 2. So same thing on the history, and then edit the script. So pretty much doing the same thing, but this time is reading from the database itself. So it reads from the test data database, which is this table name is a table in the Postgres that we have. So this is just to show that yes, we can read from S3, write it to the database, but we also can read from the database and write it back to the database. So it's like our existing ETL jobs. Sometimes we read from the source and write it to the staging table, and then we read from the staging table and write it to the destination table. So this is trying to mimic what we're doing for our current ETL. Um, so doing the same thing with the data, and then again write it back to this Postgres database, and then write it to this table, and then that. So once we finish that job, right, what I was doing is I can trigger the job from here, so I just do that, and then action, you can run the job just to test it out, or if you want to set it using triggers, or what I've done is first I set up the trigger to trigger the first job. The first job is to run is this test to delete. So this is trigger on demands. And then after that's ran, I want to run a job, which is like doing job dependencies. So the second job is run job number 2. So this one, right? Run job 2, that's the name. And then the job name is um, when the job's completed, this test to delete has been completed successfully, then it will trigger this job here. So once that's done, so and then what I have to do is I just run this job, run the first, just trigger that, And once this job is finished, then it will trigger the next job. And then at the end, that we can see this table has been created in the database. So that, and with the data inserted, so that proves it's working fine. And then, yeah, this is it. And for, let me show, there's one more thing. That's jobs test to delete. So the thing is, if you look at the how long it took for each job to run, you can see sometimes it takes 2 minutes, sometimes it takes 4 minutes, and sometimes it takes like 18 minutes. And what I found from the development guy, it says that when it runs for the first time, because it needs to set up the the what you call it, I guess the environments in the back end, that's why it takes longer. But once it's done, and the subsequent job it takes less time to run because the infrastructure has already been set, and that's why you see the jobs doesn't finish at a constant time frame. So that's that part. And then the next part I was doing is instead of doing the scripting here using the console, what we can also do is we can use the notebook that we have. So for example, if I launch my dev endpoint, so in here, right, you can also create dev endpoint. What that is like an environment for you to run your and develop and test your scripts. So what a dev endpoint is, right? It's just like setting up like an EC2 instance, and then it also install the Zeppelin notebook, and then you just point to it from your web browser, and then you can just use it as like a notebook, and then you can run jobs on it. So the one that I have, so after I set this up, so we will launch this one here. So literally this is like a EC2 instance. And what you can, if you want to see the instance, you can also go to here. So you go EC2. You will see the running instance. So this one here is the one that's used by the notebook. So once this is up, the one I was playing with is this one here. So literally in here, you see the boilerplate is very similar. And then you can just read the data, and then you can perform the same thing, literally right to the database table. So you can read the table. What's that? Yeah, read the table and also write to the database. So this part is the one write to the database. So it writes to a sales movement D copy. So we have that one here. So after I ran this part, it will create a table here, and with the data that we have as we read from here. So yeah, so we can literally use this to develop our ETL scripts. So that's the development endpoint. And also you can also like install the notebook locally and then just point to that development endpoint, and then you don't have to set up your EC2 instance here. So that's that part. Okay, so what I would like to go through now is, yeah, so that's basically what I've done for the hack day. So at the end, so what we need to consider if we're going to use this for as part of our ETL platform. Um, the first thing is there's like limitations with Glue. the first thing is like the number of crawlers for account is 10. So in here, you only can, the maximum crawlers you can have is 10. So let's say here, the number of crawlers. So you only have 10 of these. So that's why we can't just create like hundreds of these crawlers and just one crawler for each table. We can't do that. That's one of the limitation. And then the number of jobs is 25. Yeah, that's a difficult bit for us because with our current number of jobs that we have in our ETL is around 600 plus. So with that setup, right, we have to group a bunch of our jobs together into one single one. And I was thinking like with our ETL jobs, I was hoping to break it into smaller independent pieces, but with this, I'm not sure we can achieve that. That's one thing we have to consider. The thing is, these are soft limits, so we can increase it by raising a support ticket to AWS. The other thing is, number of triggers that we have per account is 25. So again, it's like another limitation that we have to think about. And number of jobs per trigger is 10. And to reload data with older schema needs to be handled manually. So this is because when the crawler update the schema, and if this new schema doesn't match with the older files, it will fail, and we have to handle this manually. And the other thing what I found is doing the data set is using crawler is because the crawler only get a sample of the data. So imagine if you have a data set which is like a million rows, and one of the columns, let's say the first 300,000 of them are null, but and then the rest of that is a number. When when the crawler get the first 300,000 as a sample and it see as a null, and then what it does is we declare the column as like a string. And when you try to load this data into there, you will face an error because the rest of the data is like a decimal. So what I've done is I have to manually change the data type manually um, within the data catalog. But the thing is, every time when I run the crawler again, it will override my custom settings because it will try to get the first 300,000 rows again as a sample and then change it back to a string. So that's one of the shortcomings that I face when I try to do my um, proof of concept. So okay, yeah, so here is like every time you run the crawler, it overrides your menu settings. And yes, there's costs with the job. So each job costs around like $7.733 per 10 minutes. So we have to be wise on how to arrange the jobs together and use the resource um, wisely because with our current setup, that will be a cost issue as well. So the other thing is the things that I like about Glue. The first thing is because it's serverless, so we don't have to worry about the servers issues, the disk space issues like we do now. And next thing is it works with the notebook. So from my previous presentation, I found out the notebook is a very nice way for us to approach on writing ETL jobs for the new data platform because it's a great way with doing testing and also great way of doing documentation on the fly. And the other thing is it can handle job dependencies using the triggers and also work with different data sources such as S3, Redshift, and RDS. So yeah, so this is what I found about Glue. Um, yeah, um, Thank you very much.